Hello, this is Keith Capillero with K-Dawg Weather. Today's PowerPoint presentation is on tornadoes. Tornadoes, understanding nature's most violent storms. The presentation agenda is fundamental of tornadoes, types and classification of tornadoes, detection, prediction and warning systems, impact and safety measures. Fundamentals of tornadoes. Definition and key characteristics. A tornado definition. Tornadoes are violently rotating columns of air extending from thunderstorms to the ground with intense wind speed. Duration of tornadoes. Tornadoes typically last from a few seconds to over an hour, with most lasting less than 10 minutes. Key tornado features. Key features include visible condensation, funnels, debris clouds at the base, and rapid wind direction changes. How tornadoes are formed. Supercell tornado thunderstorms. Tornadoes begin within supercell thunderstorms characterized by strong wind shear and horizontal air rotation near the surface. Mesocyclone formation. Updrafts tilt horizontally, rotating air vertically, forming mesocyclone, the precursor to tornado development. Tornado development. Intense stretching of the mesocyclone causes a tornado to develop from the cloud base under favorable atmospheric conditions. Influencing factors, temperature gradients, humidity, and topography strongly influence tornado formation and behavior. Common locations and tornado alley. Tornado alley region. Tornado alley covers parts of Texas, Oklahoma, Kansas, Nebraska, and South Dakota, with frequent tornado activity due to geography. Global tornado occurrences. Tornadoes occur worldwide except Antarctica, but are most common in the central United States due to very favorable atmospheric patterns. Seasonal tornado peaks. Tornado frequently peaks in spring and early summer when air masses commonly clash in Tornado Alley. Types and classifications of tornadoes. Main types of tornadoes. Supercell tornadoes. Supercell tornadoes are the strongest and most destructive, responsible for most violent EF3 or higher tornadoes. Landspout tornadoes. Landspouts are weaker non-supercell tornadoes that typically cause less damage than supercells. Waterspouts. Waterspouts are tornadoes occurring over water, including tornadic and fair weather types. The Enhanced Fujita Scale. Tornado classification. The EF scale classifies tornado from EF0 to EF5 based on observed damage and estimate wind speeds. Scale improvement. Introduced in 2007, the EF scale incorporates modern engineering studies to improve damage assessment accuracy. Practical applications. Damage survey guide, emergency management, and informed construction codes to reduce the failure of tornado harms. As you can see with the Enhanced Fujita scale, an EF0 is 65 to 85 miles per hour with light damage. EF1 is 86 to 110 miles per hour with moderate damage. EF2 is 111 to 135 miles per hour with considerable damage. And EF3 is 136 to 165 miles per hour with severe damage. EF4 is 166 to 200 miles per hour with devastating damage, and an EF5 is over 200 miles per hour with incredible damage. Tornado wind distinguishing tornadoes from other storms. Tornado wind patterns. Tornadoes exhibit rotational wind patterns which differentiate them from other storm phenomena. Identifying funnel clouds and waterspouts. Funnel clouds and waterspouts are similar but differ in location and formation characteristics. Downburst and straight line winds. Downbursts create straight line winds that contrast with rotational winds of tornadoes. Importance of accurate identification. Correctly distinguishing tornadoes is vital for issuing warnings and ensuring public safety. Detection, prediction, and warning systems. Meteorological tools for detection. Doppler radar detection. Doppler radar detects tornado signatures like mesocyclones and rotational velocity couplets for early warnings. Supplementary meteorological tools. Satellite imagery, wind profilers, and storm chasing reports support tornado detection and tracking efforts. Dual polarization radar advances. Dual polarization radar improves debris signature detection, increase real-time tornado and tornado confirmation accuracy. Forecasting and early warning. Numerical weather prediction. Tornado forecasts use models that analyze atmospheric data to predict tornado formation hours to days in advance. Warning polygon issuance. Warnings use polygonal shapes on map to highlight specific risk areas for tornado effectively. Lead times and alerts. The average lead time for tornado warnings is about 13 minutes, allowing timely alerts through mobile and broadcast channels. Roles of storm spotters and technology. Ground truth observation. Storm spotters provide critical real-time observation of storms, development, and tornado touchdowns to support radar data accuracy. Technology enhancing awareness. Smartphone apps, social media, and automated algorithms improve real-time situation awareness and storm detection. Agency coordination and preparedness. Coordination with meteorological agencies improves warning precision, reducing casualties, and enhancing community preparedness. Impacts and safety measures. Destruction and aftermath of tornadoes. Tornado damage and fatalities. Tornadoes, especially EF3 or higher, cause severe damage to infrastructure and vegetation with significant loss of life. Economic impact. Tornadoes lead over $1 billion in annual economic losses in the United States due to destruction and recovery costs. Recovery and physiological effects. Post-tornado effects include debris removal, rebuilding, and addressing long-term mental health challenges in affected communities. Historical case studies. In 2011, the Joplin tornado illustrates the catastrophic impacts and complex challenges of communities recovered after major tornadoes. Preparedness and safety tips. Very important. Safety rooms and shelters. Identifying safe rooms and shelters is critical for protecting during tornadoes to minimize injury risks. Emergency kit preparations. Assembling emergency kits with essentials ensures readiness for tornado emergencies and quick access to supplies. Regular tornado drills. An individual family respond swiftly and correctly during warnings. Public education impact. Educational programs encourage immediate protective actions, reducing injuries during tornado events. Community response and recovery. Coordinated emergency response. Emergency services, government agencies, and volunteer work together to provide rescue, relief, and rebuilding after tornadoes. Long-term recovery process. Recovery from tornado damage can take months to years depending on disaster's severity and impact to the community. Reliance and mental health support. Community reliance programs emphasize infrastructure, adaptation, and mental health support to reduce future vulnerabilities. Public-private partnerships. Collaboration between public and private sectors enhance disaster management, effectiveness, and resource ability. Conclusion. Gaining insight into tornado for better preparedness. Tornado understanding. Comprehending tornado formation and the classification reveal the complexity of these storms. Detection and prediction. Advancement in detection improve early warning to protect communities from tornado impacts. Preparation and response. Community preparedness and timely response minimizes damage and enhance safety during tornadoes. I hope you enjoyed this PowerPoint presentation on tornadoes. Please like, subscribe, and hit that notification button for more insights on PowerPoints of weather related. This is Keith Capillero from K-Dawg Weather. Have a good day.